Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the preparation of carboxylic acids. In our last lesson, we discussed the chemical properties of saturated monocarboxylic acids and the chemical properties of organic acids. We learned that carboxylic acids react with active metals to form salts and hydrogen gas. They react with strong bases to form the corresponding salts and water, and they react with weak bases to form salt, water, and carbon dioxide. We also learned that carboxylic acids react with ammonia to form ammonium salts of carboxylic acids. Since then, you have been learning about the oxidation of primary alcohols and the oxidation of alkyl benzenes. In today's lesson, we are going to explain the industrial preparation of acetic acid. We will also go through an experiment that is used to prepare acetic acid so you can understand how it can be produced in a laboratory. If you are ready, students, let us get started. Acetic acid is also known as ethanoic acid. It is one of the most important carboxylic acids and is used to preserve food. Large quantities of acetic acid are obtained industrially from the fermentation of ethanol. This process is known as the quick vinegar fermentation process. This process is done in large wooden vats that have perforated bottoms. The vats are packed with wood shavings that have been moistened with old vinegar. Ethanol solution is poured into the top of the vat, and it slowly trickles down to the perforated bottom. Air is pumped into the lower portion of the vat, as you can see in this image. Bacteria that is present within the old vinegar ferments the ethanol, turning it into acetic acid. The liquor that is obtained at the bottom of the vat is circulated back up to the top of the vat. It rains down over the contents of the vat and sinks to the bottom once again. The maximum concentration of acetic acid that can be obtained through this process is about 10%. This can be fractioned to yield glacial acetic acid, which is acid that is completely pure and free of water. Students, let us do an activity. Using point form notation, please explain the quick vinegar fermentation process.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Were you able to explain the quick vinegar fermentation process? Let us go through it together. The process starts with a large wooden vat that has a perforated bottom. Wood shavings that are moistened with old vinegar are packed into the bottom of the vat. Ethanol solution is added, which trickles through to the bottom. Air is pumped into the bottom of the vat, and the bacteria present in the old vinegar ferments the ethanol into acetic acid. The liquor that collects at the bottom of the vat is recirculated through the tower and over the contents of the vat. If you were able to explain the process correctly, good job! Students, acetic acid can also be produced in a laboratory by the oxidation of ethanol with potassium permanganate. It can also be prepared by passing the vapors of ethanol through copper oxide. Let us look at an experiment that creates acetic acid using this method. To begin this experiment, we would set up the quick fit apparatus for refluxing, which you can see in this image. About 10 milliliters of 1 molar sulfuric acid is placed into the 250 milliliter round bottom flask. Add 2 to 3 grams of sodium dichromate and a few pieces of broken porcelain. Swirl the contents of the flask until the solution is complete. You can warm it, and that will move the process along. Cool the mixture by running it under the tap, and then drop 1 milliliter of ethanol into the flask. Boil this mixture under reflux for 20 minutes, and then distill 2 to 3 milliliters of the liquid. The smell of the product, or distilled liquid, will be quite different from the ethanol. Add a few drops of the distilled liquid to a small amount of solid sodium carbonate, and add a drop of the distilled liquid to moisten some blue litmus paper. The color of the solution in the flask will remain the same throughout the experiment. However, as we said, the smell of the product, which is the distilled liquid, is different from the smell of ethanol. The chemical equation for this reaction looks like this. The role of sodium dichromate in this reaction is to oxidize ethanol to ethanoic acid. Students, what can we conclude from this experiment?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. From this experiment, we can conclude that acids can be prepared in the laboratory by oxidation of primary alcohols. In today's lesson, we discussed the industrial method used to prepare acetic acid. We learned that it is called the quick vinegar fermentation process, and that acetic acid with only 10% concentration can be obtained through this process. Pure, water-free acetic acid can be obtained by fractioning. We also talked about the laboratory method used to prepare acetic acid. We went through an experiment to show this process and concluded that acids can be prepared this way by oxidizing primary alcohols. This brings us to the end of our lesson for today. In our next lesson, we will learn about esters, including some common sources of esters and the general structural formula for them. Until next time, thank you, teacher. Thank you, students.